right, so we're on Newton's third law, and this is his final law. So this is the last one we have to talk about. After today's notes, go ahead and watch the video that I have posted on Newton's third law because it explains it in more detail. And then you have your assignment for Newton's third law. Again, there's no math today, so don't worry about that. So today we're going to discuss how all forces occur in interaction pairs, and you're going to be able to describe Newton's third law. All right, so we talked about net force before. That's the total force. Anything that's not a zero is going to cause a change in motion. Just keep that in mind for today's lesson. Again, anything that's not a zero is going to have a change in motion. So we talked about Newton's second law already last week. Again, it's just mass times acceleration. The difference between second and third law. Newton's second law focuses on one single object, but Newton's third law is going to focus on two objects. So forces are always going to come in pairs. An interaction pair is two forces that are opposite directions and have equal magnitude. So the forces A on B and the forces B on A are an interaction pair. So whenever you exert a force on your friend and you push him forward, he's going to exert an equal and opposite force on you, which causes you to move backward. Don't ever push a friend in real life. I'm just giving this as an example. Newton's third law states that the force of A and B is equal in magnitude but opposite in direction of the force of B on A. The two forces in a pair act on different objects and are equal and opposite. So it's kind of like that question I asked you last week when you're holding a box up. Well, if the weight was 75 newtons, how much is the normal force going to be pulling it up? 75 newtons. The only difference is normal force goes up, weight goes down. So they're equal but opposite. So again, Newton's third law states that forces come in pairs. Two forces in a pair act on different objects. Both forces are equal in strength and opposite in direction. For every action force acting on an object, there is a reaction force acting on a different object. And the action and reaction forces are equal in magnitude but opposite in direction. So when you're identifying the pairs in an interaction pair, remember that they always occur in two different free body diagrams. So they each have their own free body diagram. And they're each going to be going in different directions. So here's some examples of action and reaction. A shuttle pushes on gas, the gas pushes on the shuttle. A woman pulls on the spring pulls on the woman. A tire pushes on the road pushes on a tire. Earth pulls on a ball, the ball pulls on an earth. So again, they always come in pairs. There's an action and there's a reaction. And then remember, forces can be categorized as internal forces or external. External forces include applied, normal, tension, friction, and air resistance. All right, so that's all I needed to talk about. Go ahead and work on your Newton's third law assignment. I'm gonna stay on Zoom the whole time if you need help on that. If you have any questions, stay on. If not, you are free to go.